Hello everyone, welcome back to my channel and this amazing video. Today we are going to see using decision tree algorithm with FastAPI. So we will be doing a FastAPI backend where we will have a decision tree algorithm model, and we will make requests from our Nuxt app and get the most accurate predictions. So without any further ado, let's begin. So before we dive into the code, let's briefly see what is decision tree algorithm. I won't be dwelling much in the theoretical concept because they are boring. So I'll try to keep it as minimalistic as possible and try to just summarize the decision tree algorithm in as simple words as possible. Okay. So decision tree algorithm is a predictive analysis algorithm. Okay. So in machine learning, there is descriptive analytics, predictive analytics, and prescriptive analytics. So decision tree algorithm is predictive analytics. There are two types of decision trees, which is classification and regression. So classification tree, as the name suggests, is used when the predicted outcome is classes. So for instance, let's take an example. Suppose I have a car like without any logos or anything, and based on certain parameters, I want to predict which company this car belongs to. So it could be Hyundai or Toyota or Honda, all those companies. So each company name is nothing but the class. Okay. So in this case, to predict the exact brand of that car, we will use classification tree. Now let's take another example for the same car. Suppose if I want to predict the average of that car, in that case, I will use regression tree algorithm. So here we are predicting the accurate number or the real number. So in this case, when we are predicting a number, we will use regression tree. Another example of regression tree is pricing of houses. Now, decision tree algorithm stands on two core concepts, which is entropy and information gain. To be precise, entropy in this case we'll be using Gini, which is slightly different than entropy, but the main purpose of Gini and entropy is nothing but to measure the randomness. So the measure of randomness is entropy. Information gain, on the other hand, it relates to the information theory, and it refers to, like, it helps you to choose the best possible features to make decisions, or the best possible attributes that renders maximum information about a class, as the definition says. So our aim here is to maximize information gain and minimize entropy. Okay, so we have to maximize the information to reach the best possible class, and we have to minimize the randomness. So this reduction in randomness is nothing but information gain. Okay, so let's take an example, then it will be more clear. So let's take an example of playing tennis. So I will play tennis. Suppose if I want to play tennis, I will play when the weather is overcast. So this is, you can consider like a trained decision tree model. So here, if the weather is sunny or if it's rainy, we are considering other factors, which is humidity and wind. Okay. In that case, we are again considering that whether the humidity is normal or high and wind is strong and normal. So in general, when we choose weather as a root node, our number of randomness, or the measure of randomness, which is entropy, becomes low, and our information gain becomes high. Okay, so when you choose nodes for the decision tree, you need to make sure that the order you choose the node is very accurate, because if I choose humidity first or wind first over weather, my entropy will increase and my tree won't be accurate. So in that case, I need to make sure that the nodes I choose are based on the fact that which node provides me the maximum information gain, because our aim is to maximize the information gain. These amber colored nodes or yellow colored nodes are known as leaf nodes or class nodes. So our class here, or classes, are yes and no. So we are reaching to a decision of either we play tennis, which is yes, or we don't play tennis, which is no. So that's the final outcome, or in simple words, these are our two classes. Humidity, weather, wind, these gray boxes are nothing but decision nodes. Why? Because these are helping us to reach these classes. Okay, so this is what decision tree algorithm is in nutshell. So now let's see the code and let's see how we can do it in FastAPI. So I will be using a dataset from Kaggle. So if you are new to Kaggle, Kaggle is a website where you will get dataset for machine learning algorithms. So you will get a dataset in CSV files. It's open source, I guess. Yeah, it's mostly open source. And you can use this dataset to test your machine learning algorithm. It can be anything. It can be k-means, neural networks, decision tree, KNN, anything. You will also see a code section where you will see other people, they have used, like they have given their code, which is very amazing, and it shows like how, like it's very actually useful also to learn how they have achieved higher accuracy and how they have changed it differently or how they have done it differently. So it's very interesting website. So we will be using this cars data, and you can interpret this data in several ways. So how I'm going to interpret is, but so I'll just tell you originally how it is there, how it is interpreted. So we have some set of inputs till here. So it starts from MPG and goes all the way. So I guess there are 6 or 7 inputs, and it goes all the way to year. So if I do compact, then I can see everything. Yeah. So till year, and based on that, it predicts in which country the car was made. So it could be US, it could be Japan, or it could be Europe. Okay. So we have these 3 classes. This is Japan, Europe, and US. How I'm going to deal with this is, I'm going to drop this year column and going to use other parameters to predict in which country the car should be manufactured. So based on this MPG, cylinders, cubic inches, HP, weight, time to 60, I'm going to see in which country the car should be manufactured. So let's see what we have on our front end. So I have a simple form here, which is just having some like 6 input fields. And if you haven't seen my Nuxt tutorial series, actually, by the way, so it's just the extension in that code. So please do see the Nuxt tutorial series and you'll come to know like how I have set up this project. So getting back to our main topic over here. So I have this input form. This is going to make a post request to our FastAPI, and then it will just give us a country name or the region name where the car should be manufactured. So let's see what we have on the FastAPI side. So if you are new to FastAPI, it's nothing but a Python web framework to create API endpoints in Python. So you can create REST APIs, you can create Graph API, like anything of your choice. All you need to make sure is you have Python 3.6 plus and you have pip installed. So I have already installed Python and pip and also FastAPI. So I won't be installing it again, but I'll just tell you the steps how to do it. So once you install Python and pip, just follow this command, pip install FastAPI. And once it is installed, make sure you install UVCon. So in simple words, UVCon is nothing but an environment to run your FastAPI code. Now it's like you can see it as a pro, but some might see it as a cons. So the main pro or cons of FastAPI is that it do not have a project structure. So if you choose frameworks like Laravel, Django, or any other web frameworks, they have a project structure, like a directory structure. But in FastAPI, there is no directory structure. So you need to create each file by yourself. Same like Express, but in Express, you just have package.json and you create app.js or server.js, and then you write all the Express code there and then expand your project directory. In FastAPI, you start with an entry file or a main file. So I'm going to create a main.py. You can name anything to this file. It doesn't matter. So let's go to VS Code. And here I have CSV file. Now here I'm going to create a new file. So I'll say main.py. Now what we need to do, we need to import from FastAPI, import FastAPI. And then we need to create instance of it. So we say app equal to FastAPI. And now we will use a decorator to make the route API endpoint, so the get and post endpoints. So a decorator in Python in simple words is nothing but a design feature which allows you to expand the functionality of your object. So let's create app.get, and if I do like a /, so this would be like a root directory, root route, and then after a decorator you need to write a function. So I'll say def, if I say print hello, so this function will be executed once we hit this URL. And then if I say return hello world, so this function will be executed once we hit this URL, and make sure each decorator has only one function. Okay, so let's run this code and let's see what we get. So I'll go to my browser and just hit the URL. So 127.0.0.1 8000. Of course, we haven't started the server. So let's start the server. So if I go over here, all I need to do is say ubicon, then name of my file. Here it's main.py. So I need to make sure I just write main, not .py. So I'll say main app and the option of reload. Now I don't need to make changes. It will automatically reload or refresh itself once I make any changes. I don't have to do it manually. So if I just refresh this, I will see hello world. Another interesting thing about FastAPI is if I go to /docs, it will provide me my API documentation, you could say. So here you will see it uses Swagger UI. So it just shows me like for the forward, like the route, what the expected parameters and what's the expected responses. So now let's create another request, or sorry, another route, and we will say app.post, and this will be our predict route. So I'll say predict. And here, let's have a function to do prediction. Okay, so let's write here return something. We'll return it later. So for now, we'll just say predict. Now, also make sure once you download this cars.csv or any CSV file, make sure you have removed all the spaces in the file. So sometimes you might have comma space brand, so remove this space. Also, you might have comma space US, so remove that space also. So just remove all the spaces. So now once we have this, let's create a Pydantic model. So what is a Pydantic model? So in web frameworks, you have a database models which are related with your SQL database or any other database. So in FastAPI, you don't just have a database model, but you also have something known as Pydantic models. So Pydantic models, you can consider it nothing but a schema of your request or response. So I'll tell you what exactly it is again. So if I go here, create a new file, schemas.py, and here all I need to do is write import Pydantic, or rather from Pydantic actually, import base model. Okay, now if I go to FastAPI documentation and if I type here Pydantic model, so these are nothing but used for request and response validation. So you will see that it's a class and it just has a key value pair. So what we will do, whatever input we have on our Nuxt app over here, this one, so we'll just copy this and put it over here. First we'll make a class. You can give any name to this class, but make sure that it, like the name says what the class Pydantic model is for. So you will say predict request, and I will say base model. This means it is extending the base model. So if you haven't seen my Python object-oriented programming tutorial, please do check it, because I have explained the concept of inheritance and everything over there. So please find the link in the description below and make sure that you have a look on that. So here we will just paste what we copied, and we won't leave it just there. We need to make certain changes. So let's remove this comma also. Let's remove this, this, and this. And then these are our keys. So this will be the input that we want, and we will give it a type of float. Now this model will make sure that whatever input we get is in this format, and each of its type is float and it is required. If I want to make it optional, then I have to use from typing import optional. And then all I need to do is just put here optional, and then this MPG will become optional. So I can keep it blank when I send the request, or I can put some value. So it becomes optional. For now, we don't want anything of this as optional. So we'll keep it everything required. Now, how to use this Pydantic model in our request? So here I'm going to import it first. So I'll say from schemas, import predict request. And then here in the function we will pass predict, which will be the type of predict request. Now if I save this, if I go to my Swagger UI documentation, and here you will see that the request body is required. So these things are required. Now if I go back again over here, and let's remove it from here for now. Oops, like this. And if I refresh this, you will see it says no parameters or no bodies required. But if I go back again over here and just undo it and now refresh again, so it will tell me that these things are required. Now let's try it out. So if I execute, I should see predict. Okay, that's great. Now let's try to make a request from over here. So if I go over here and just simply hit predict, you will see it gives me coarse error. So what is coarse? To avoid certain cyber attacks, and it makes sure that only the origins you have allowed or the URLs you have allowed, they can only access your backend or your server. So if I go to FastAPI and then coarse over here, it will tell you how to use or how to configure coarse in your FastAPI project. So let's do this in our project. So I will go here and I will say from FastAPI.middleware.coarse import coarse middleware. And then I need to define the origins. I can have these origins in different file or in like maybe an environment variable or something, but I'll keep it here only for now. So I'll say origins, which will be nothing but the list of origins that are allowed. So my URL would be this 27.0.0.1 3000, and you can also allow another origin, which would be one HTTP localhost 3000. So we can use these both URLs to make requests. And next thing would be, once we have this, we need to configure our course. So if I go back again over here, you will see we need to add the middleware to our app. So I'll just copy this part of the code because it's too much to write, and let's paste it here. So we need to just push this app at the top over here, yeah, because Python executes line by line. So once we have this, now you will see that we are allowing these origins, credentials, we are setting it to true. Methods, we are allowing all methods for now. Headers, we are allowing all headers for now. So let's check it now. And if I go over here, just remove this. If I hit the predict again, I shouldn't see those errors. So now it's giving me another error, which is 422. This 422 is coming because we haven't put anything here. So if I go again to my Swagger UI, and if I just remove one of these and then execute, I should get 422 again, because we are missing parameter. We are missing certain parameters. So again, this is just making sure that we are validating everything. So to handle this 422, what I will do is, in our Axios, after then we will have .catch, and then we will have error, and we will just alert error. Let's console the error and let's see what we are getting. Console.log error. And now if I go again over here, you will see it says request failed with status code 422. Now if I go here again, we can say, like, we can apply validation, sorry, not validation, but if we see something like if error message, let's do like this, if error.message.index of 422 is greater than -1, we just alert you need to put all the messages, you need to fill in all the fields, and like this. Go back again over here and say you need to fill in all the fields. You can also avoid this by having an HTTP exception over here. So if something goes wrong, then you could have HTTP exception. So you can handle this error in several ways. So once we have this, now let's proceed forward. We need to create, or we will create actually a separate file, which will be our decision tree algorithm, or the code for decision tree algorithm, where we will have our model, and then we will just use it in this function and get our result. We can also write the code here, but it will get a bit messy. So let's keep it in a separate file. So let's create a separate file, decision tree algo.py. Now here we will first say import pandas as pd. So pandas will be useful to read our CSV file. So let's do that. So we will say file equal to, it's a variable, pd dot read CSV, and we will give the name of our CSV, which is cars.csv. Now if I print file.head, it will show me first 5-6 rows of my file. So if I run this, you'll see I'm seeing like first 5 rows of my file with the headers. Now next thing I need to do is I want to drop this year column. I want to convert, okay, let's first drop the year column, then I'll explain it to you why, what we have to do with this brand. So I'll go here and I will say file equal to file.drop, and here we need to specify the column that we want to drop. So it would be year and then file, sorry, not file, but this will be access equal to columns. So now if I go back again here and print file.head, so it will show me all the data except that year column because we have dropped it. Now once we drop that, now let's deal with this brand column. So if you see, it's alphabetical values, and our system, or machine learning, in machine learning only numeric values are understood by the system. So we need to make sure all these alphabetical values, they are converted to numeric values. So let's do that. So for that we will be using, so there is another library which is sklearn. It's a very amazing library if you are dealing with machine learning algorithms in Python. So I'll say from sklearn.preprocessing import label encoder. If you haven't installed, or if you see some errors for sklearn or pandas, you can install it using pip installs. Once we have this label encoder, now let's encode this brand. So each label, which is US, Europe, and I guess the second one is Japan. So each one will get a numeric value. So we'll say here file equal to, or rather let's take it in a different variable. So we'll say target column equal to, and we will say label encoder. So this will be the instance of this label encoder. Now what we need to do is we need to add an extra column to our file, this file. So we'll say file, and that column would be brand numeric, which would be nothing but target column dot, and we will use this label encoder's fit and transform function. So fit, actually we don't need this extra step, we could straight away use this over here, but it's okay, we can just use it like this. So we will just create an object and then we will use it. So we'll say label encoder dot fit and transform, and here in this function it takes certain parameters. So the first the only parameter that we need to give is the column in the array that we want to, or in the list that we want to transform to a numeric value. So I'll say file brand. So now this brand over here, this thing will become or get a numeric values. So now if I run this and print it, so you will see I'm having brand numeric where US has 2, Europe has 0, and Japan will get 1. So once this is done, the next thing to do is remove this brand column. Okay, but before that we will create another column which is target association column. You'll come to know why we have created this, but for it will be mostly you'll come to know at the end of the code, but till then just please bear with me. So here we will create a target association, and here what we are going to do, we will say file and we want to create a 2D array of brand numeric and brand. So we'll say brand and the associated brand numeric value of it. Okay, now after we have this, we need to drop this brand column as well. So what we will do, or rather, let's bring it over here. We can do it in one line. We can drop multiple columns at the same time. So we will do year, and we will also drop brand because we already got the numeric value. Now if I run this, yeah, everything works great. So now let's proceed forward. So once we have our data being set properly, now we need to divide it into inputs and targets. So what I'm going to do, my inputs are nothing but these 6 things. So everything except brand numeric is my inputs. So I'll take another variable here, inputs, and I will say file dot drop, and I want to drop actually this brand numeric, which is nothing but the column. And if I print my inputs, you'll see I'll get only the inputs except the brand numeric, and here it is. So this inputs, so in machine learning, in the classification algorithm, we have inputs and the targets. The targets are nothing but the labels. So once we have this, now let's create the targets. So the targets would be nothing but this brand numeric. So we'll say file brand numeric. Bear in mind that here we have dropped the column and then assigned it to the file. That's why to the new variable or the new value of the file, when it comes here, it won't have these two values. But in this case, we are assigning it to a different variable. So in there, we will have this brand numeric value even after we drop it over here. Okay. So once we have targets, so if I print targets now, print it again, and we will see our targets. So all the targets are here. Okay, that's great. Now let's proceed forward. So the next thing we need to do is we need to create the testing data and the training data. So we'll say x train comma x test and y train y test equal to, we will use train test split function. So that will come from our sklearn. So it's from sklearn dot, I guess it's double dot here, sorry, model selection. We want to import train test split function. So I'll say train test split. Now this function will take what we want to split. So we want to split our data into training data and the test data. So make sure this order is as I have written it here. So first we have the X train, so the input training set, the input testing set, the output training set, the output testing set. So what is this training and testing? Okay, so in simple words, we are using this train data to train our model, and we are using this test data to test our model. Okay, so here I'm going to say train test split, and I'm going to use inputs. So this will be splitted over here in the ratio of split that I will give. So some will go to train, some will go to test. Then I have my targets. So this will go to over here, and I need to give the another parameter here, which will be test size. So this will be the ratio or the decimal value. So how big I want my test data. So this general split is 80-20. You can also do 70-30. So where 70% is train data, 30% is test data, or 80% train data, 20% test data. I will do 80-20 split. So 20% is the test data. After that, I need to do this random state equal to 1. Now once we have this, we have our training data, test data, and training target, test target. Now let's create our model. So to create our model, first thing we need to do, we need to from sklearn, we will import tree. Okay, and here we will say model equal to tree dot decision tree classifier. Okay, Now, once we have our model or the decision tree object, which is our model, now we need to train it. So we'll say model.fit. Now I can use this xtrain and ytrain, but I'm going to use inputs and targets. So I'll say inputs and targets. And then once I have this, I can make prediction. So I'll say, so till this stage, our model is trained. So first we will use inputs and targets. Then we will see the accuracy of the algorithm. Then we will use xtrain and ytrain, and then we will see the accuracy again. So if I go again over here, and now if I do y prediction, so it's just a variable. And if I say model dot predict, and here I need to pass, so first I'll pass the test data. So these are nothing but the data frames. So this file is also one data frame, and this predict will also take a data frame. So it will be a 2D array. So we'll say x test. This x test is also already a 2D array, so we don't need to write 2D list over here. So once we have this, let's print the accuracy of this. So I'll say accuracy, and let's concatenate and convert whatever value we get into string, because it's going to be a numeric value. I will use another function or another functionality from sklearn, which is metrics, to get the accuracy. And I will here say metrics dot accuracy score. And what accuracy score I want to do? I want to do score with y test compared to y prediction. So our test targets compared with our actual predictions. So if I run this now, it's throwing me an error saying input contains nan infinity or a value too large for data type float 32. This is because in our data set there are certain extra values being entered, which has like nan or infinity or something like that. So to avoid that or to clean that, we will use numpy. So here I will say from import numpy as np. And then all I need to do here before I assign inputs, I just need to say, or rather after I assign inputs actually, I will say inputs equal to, let's clean it. So we'll say np dot nan to num, and what we have to convert nan to num, so inputs. So what this is going to do is this nan to num, wherever there is nan, it will substitute that with 0, and wherever there is infinity, it will substitute with it infinite number. Now if I run this, I will get an accuracy of 1.0. 1.0 is 100%. So now let's do with, here we have model inputs and targets. Let's do with train data. So we'll say x train and y train, and let's see what we get. So the accuracy here we got is 79%. You see, so this is how it differs. So once we have this, now once we got our accuracy as well, let's change this back to inputs and targets. And now let's use our inputs, not these inputs, but the inputs that we get from over here, and pass it over here. So what I'm going to do, everything what we have written here, I'm going to wrap it into a function. So I'll say def decision maker, and let's paste it over here. Oops. So let's take it like this, and here we will pass this predict, this one. So we'll pass it over here. So say predict. And another thing we're gonna do is here in the model.predict, we will say our data frame. So we will say predict. So again, we need to follow the same order over here that we have, else we won't get the accurate result. So first is mpg, so we'll say predict.mpg. Then it's predict dot, I guess it's cylinders, yes, then cubic inches, cylinders, predict dot cubic inches. If I follow the correct over here, yeah, cubic inches. And then we have HP weight elves time to 60, we have predict.hp predict.wait. Else, if I have written it correctly from here, oh, it's just wait, it's not wait else. And we have predict dot time to 60. So I go back again over here, we have predict dot time to 60. Okay, so once we have all this, so then we will get our predicted result. So we will remove this from here and let's print this y predict so we can see what exactly we are getting. So if I save this, and now we need to use this function in our main.py. So I will say from decision tree algo import this one, decision maker, and here we will just first run that function. So it's a decision maker with predict. Okay, now once we have this, let's run this. So if I go to our code in our fast Swagger UI, so let's run this with this values only. So we'll say mpg maybe 0 again, and let's see what we get. So if I execute, we are getting error, that's fine. And here you'll see we are getting the array, which is, so it is, yeah, okay, so we did something wrong here. So let's go back again over here. So yes, this should be 2D array because again it's a data frame, so it should be like this, 2D array. Yeah, now it should be okay. So if I click execute, go back over here, you will see I'm getting 0, which refers to, if I'm correct, it refers to Europe. So now if you see, this 0 is a numeric value. Now how can I associate it with the alphabetical value? That's why we created this target association. Okay, so this is nothing but having a set of 2D arrays. So there is target association brand, and it's an array again, or a list, then target association brand numeric, then a list again, and each key of that list corresponds to the appropriate numeric value of it. So suppose the 0th index value of this brand list would be equivalent to 0th brand numeric index value. So how we can deal with this? It's pretty simple. So we don't need this, so we'll just comment this out, and we will then go over here and let's do like this. So once we have our y prediction, we will say for item in target association, and that is brand numeric. Okay, now if item equal to, or rather let's do like this, k in range of brand numeric, and we will save like this. We can also take a key value pair actually, but let's go with this, like here key, and but I guess it might throw an error, so just be on safer side, we will go like this, and then whichever corresponds to this we'll just put over here, and instead of brand numeric we'll say brand. Okay, okay, once we have this, so this brand region is taking this value, and then let's print this brand region, say brand region. Okay, now let's go back again here, execute, and if I go over here, so it says k series object cannot be interpreted as integer. Okay, that's fine. So let's see what's the problem over here. So if I go back again here, and if I do it, execute, so it shows me Europe. Now I want to pass this Europe to our front end. So what I'm going to do here, I'm going to say return brand region, and in main.py I'm going to say return region and whatever the value of this brand region is. Of course, you might need to put extra validation here to make sure that this run correctly, and also you can save this model using pickle. So it's another library. You can save, like, you first save the model, and then once the model is ready, it will be a .pkl file, and then you can load the model again, and you don't need to follow all these steps because it's already loaded. Okay, so we won't save and load it for now. We'll straight away run through this because the data set is also small and it's not taking that much time anyhow. So once we have this, now let's go back to our code of Nuxt over here. Let's make a request, so it will again throw an error. So let's refresh this and remove this from here. Let's type some value. Let's say 21, 21, 21, 21, 21, 21, and let's see what we get. Now I'm getting error, so I just need to restart it and it worked fine. So we just need this region. So let's take another variable here. So we'll say maybe something like const region equal to ref of blank, and let's put this region dot value equal to res dot data dot region. Okay, and we'll just send this or return this over here so that we can use it over here. And then here we'll just copy this line because we'll just need to show what region it should be manufactured. We'll say vif equal to region, and we will say the vehicle should be manufactured in region. Let's give it a class that text green, maybe it's just tailwind class, so just a success message kind of thing. And let's then try it out. So let's refresh it first. Let's try it out now. And it says vehicle should be manufactured in Europe. Now let's do some let's go back over here, not over here actually, let's go over here and let's just use this data. So if I want to see, so if you see for US, the weight is more than more than 3,000 actually mostly, and the capacity is around 400. Okay, let's take this example straight away and we will see if we are getting US. So if I go back again over here, let's just remove this actually. Let's paste it over here. So we'll say 8, 400 cubic inches, 150 of HP, weight of 3761, and time to reach is 60. And if I remove this, now I should see here US. Yes, we are seeing US. Now let's do a similar. So if I say maybe this should be around 450, and I want this to be around maybe 175, and the weight should be around 4,000, and this should be around 5. So this should give me US according to me, but let's see. And yes, it's still giving me US because these values are nearest to that US class. So this is how decision tree algorithm works. Now let's see how it works for Japan. So if I go over here, let's take this example of Japan. So if you see the displacement and the weight is low in this case. So if I just paste the values here, let's do 4, yeah, it's 89, then HP 62, weight is maybe, let's do 2000, so we can see the nearest value, and 17. And if I see this, I should now see Japan. Let's see if I see, yes, we are having Japan. So this is how we could do prediction, and this is how we could connect our machine learning model with our front end or web, like web front end or our web app. So that's all from me for today. Hope you enjoyed this video, and if you feel that this video is worth sharing, then please feel free to share this with your network. Also make sure that you subscribe to my channel if you haven't done it yet, and also make sure that you like this video if you like it. So that's all from me. Till the next video, goodbye.